Now, we're going to use the same sequence here, but we're going to approach this as if it is a geometric sequence. So that means we're going to get some different values here. But essentially, very close to the same strategy. We've already established to get from 1 to 100, we have to, let's see, before we were adding. Since this is going to be geometric, that means multiplication has to happen here. What do I have to multiply 1 by to get to 100? Luckily, it's a nice, easy number. 100. Now, this isn't one step. You gotta multiply 1 times something, and you gotta multiply this mystery value by something to get to 100. So I gotta break this up twice. Now, the same multiplication is happening twice, which means I'm using the same value to multiply twice. So I need to figure out what value can I multiply twice here. So all I have to do, x times x, gets me to 100. I can rewrite this as x squared equals 100. Because anything times itself, that's basically, an exponent. So now I gotta figure, how can I get from x squared to 100? I'll find the square root of 100. Square root of 100 is 10. I could also use negative 10 here. So I have 2 possible values here. In this case, I'm okay if you just use positive 10. But just recognize that I could have 2 possible values for each of these now. Because now I could have 1 times 10 could give me positive 10, or I could get negative 10. But then I know times 10 or negative 10 will get me to 100 here. So I could use either of these. I'm just going to stick with 10 though, keep it easy. 100 times 10 gives me 1,000. 1,000 times 10 gives me 10,000. Alright, now I gotta go backwards. If you remember, going backwards, I got to use opposite operations. Now going forward, I did times 10, Going backwards, I got to do divided by 10. In this case, I'm going to leave it as a fraction. I know a lot of us want to go to decimals when we do this, but you're going to find that sometimes you're not going to get a perfect answer. So I like to take the approach of, let's do a lazy man's division problem, or a lazy person's division problem, which is just a fraction. Alright, 1 over 10. Is there a common difference or ratio? Now this time, since it's multiplication, it's a ratio. Going ahead, I do times 10, so that's going to be my common ratio. Write a recursive formula for the sequence. Now if you remember, I'm going to go with, let's see, we used n before. Let's see, we used x here to represent our multiple. I'm going to go with, I'll use a different one. I will use v. Why? For value. Why not, right? So f of v. Now in this case, I'm going to do, let's see, what did I do to each previous value? I multiplied by 10, so represent previous value, it's going to be f of, and then I'll take v minus 1, which represents previous output. I'm going to multiply that times 10. Again, I could also say it's also times negative 10. I wasn't requiring that for this assignment, but just be able to recognize that you multiply by 10 or negative 10 and it would still get you there. Alright, now for my explicit formula. Let's see. I'm going to go with f of v. I'm sticking with my variable this time. Now, again, I like to start out with my initial value. Again, I gotta go backwards. Now remember, that first number, this is not your initial value. If I were to make a table out of this, which I will, very basic. To represent my first value, second, third, fourth, fifth. I need my initial. My initial would be if my input was 0. So I gotta go backwards one more time. Divide by 10. Now remember, when you're dividing by 10, you're multiplying by the reciprocal, which is 1/10. So 1/10 times 1/10 gives me 1 over 100. So 1 over 100 is my initial value here. So I'm starting with 1 over 100. And then, what am I doing? What's my change here? My common ratio is times 10. And since this is a geometric sequence, it means it's an exponential function. I need an exponent. My input would be my exponent. I'm using v this time, so there you go. That is my explicit formula. I'm almost done. Now I gotta graph the sequence as a function. Now, I opted to go with the positive values here, so I do not need all 4 quadrants. And again, you don't have to go crazy with the graph. I'm just looking for some very basic stuff here. Now, my initial value is really close to 0. It's like 1 over 100. So I'm going to put that dot really close to my origin here. Really close. I'm even going to establish that. It's going to be 1 over 100. If I go back up here, wow, I've got a lot of inputs here. I'm probably going to make my highest input here 100. That way I can get in 3 values. Okay, now my next one, let's see, I'll even just kind of break this up so you get an idea of what things should look like. And you know, I don't typically go very crazy with my graphs here, but I just want to establish something. My next value is, again, really close to my origin. It's going to be 1 and it's going to be 1/10, so I'm going to put this really close here. And you might be eyeballing and saying, Mr. Gamache, it doesn't look great. But here's the thing, that's why I label my ordered pairs here. That way, you don't have to guess what I'm trying to represent here. And you can have a bad graph, essentially, and you can still say, alright, well, I know what these values are supposed to mean. Now when my input is 2, I have an output of 10, so this will look a bit better here. Input of 2, output of 10. Now here's where it gets interesting. My input is 3, I'm going to have an output of 100. And I'm going to graph that up here. Again, I'm going to label it. And this is the important thing to recognize when you have an exponential function. You should be getting a curve. If you're graphing a line, something went wrong. Notice we're going to get a nice curve up like this. And you could have gone further with it. I just wanted to go with 3 values because that's really all you need, at least for right now. So there you go. That was the assignment you guys worked on. So if there's something to take from this, remember, when you're given a sequence, that first blank is not your initial value. You're going to have to go backwards. And also remember, when you're writing recursive formulas, f of blank minus 1, whatever variable you want to use there, that's going to always represent previous value. Initial values are very important as well. Excellent. Hope you did well with this. If you have any questions, you always know you can reach out to me.